Hi, everybody. Thank you so much for taking the time to join our presentation today. I am Elaine Kwok. I am the Senior Director of Marketing at Peak Power. And if you're not familiar with us, Peak Power deploys, operates, and optimizes battery storage, grid interactive buildings, and electric vehicles using a single software platform for customers and our partners to pursue net zero goals, cut operating expenses, and unlock new revenue opportunities. Our technology transforms large commercial buildings and industrial facilities into the cornerstone resources in a decentralized electricity system. And our creative financing approach is designed so our partners make money to be that energy resource. So in the end, we all get cleaner, more reliable, and more affordable electricity. We have two amazing presenters that will be taking you through the operation and control of battery energy storage systems today. If you have any questions at all during our discussion, you can drop them in the Q&A feature. It's at the bottom of your screen. And you can also upvote other questions as well. So we are going to collect the most upvoted questions and answer them in that order in the question and answer portion after our presentation. And also, if you have any questions or any comments during the presentation, feel free to drop them in the chat below. So our presenters today, we have Funto Oshunmakinde. She is our market operations analyst and part of our market operations team that controls our customers' batteries. And we have Archie Adams, our director of business development. He works with our customers at the beginning of their battery journey to help root out what their needs and their expectations are. So with that, I'm going to turn this over to Archie. Thank you.
Great. Thanks, Elaine. So we're excited to host this. This is the third in our series on energy storage and sort of education and answering some common questions from customers. I'm excited to have Funto with us today with some in-house expertise. So to start, we're going to do a little bit of reiteration. So looking at different models for ownership and operation of a battery, in-house versus third party, looking at how the operation works. And this is where we're going to turn it over to Funto. Manufacturing versus office buildings, how those are similar and different. I'll talk about the savings and revenue streams and how the battery really makes money. And then Funto will talk about operating for demand response and charging for savings and revenue. All right, so in-house operation, this is meaning that a customer, say a large commercial facility, has a battery and they want to operate it themselves. So that can be great. It gives you control and flexibility. It keeps it all in-house, right? So it's your own battery, your own data from your facility. You're managing your savings, and you're learning how to do it and developing that expertise. The downside of doing it yourself is that it does require some specialized expertise. I would say that it's not simple, and it does add some operational burden to the facility managers, for example, when they could be doing other things. So third party, which is the Peak Power model, that's us coming in to manage that and doing that remotely. There's no capital required to do this, right? It's outsourced, and we're sharing the revenues to do this. There's not that same operational burden on your facilities. And then it's really scalable. So if you have a portfolio of projects that you're looking to grow and to kind of replicate a successful model on other projects that say your company owns, working with somebody like Peak Power is a good fit. The downside is that you don't have the same direct control of it, and you are working with a partner like ourselves. I think there's certain ways to ensure that data and privacy is kept with you and certainly managed properly. So I'll turn it over to Funto to discuss operations further.
All right. So thank you, Archie. So on the screen right now, so we have like an eye-level diagram of how the battery operation works, like the different components involved for the battery operation to be successful. So I will just discuss like each of the components basically. And then so we have, you can see the battery host site. So, the battery host site, so the battery energy system is installed at a specific location, right? So that's what we call the battery host site. So it's typically near the electrical load. aims to support, right? So the site could be a commercial or industrial building, could be a residential property, or any other facility with energy requirements. And then so you'd see there's the battery, which you can also call it the battery energy storage system. So this can be installed in front of the meter or behind the meter, right? Depending on the intended use of the battery. So for behind the meter systems, they are typically located on the customer side of the electricity meter and is directly connected to customer's electrical load. And then this, the behind the meter battery energy storage system, it can be used to provide benefits like reduced energy bills directly to the customer or site where they are installed. And then, but for like the in front of the meter energy storage systems, those are usually located on the utility or the grid side of the electricity meter. So this is usually, they're usually focused on supporting grid operations directly or addressing broader grid-related challenges like the frequency regulation, right? And then, so we have the electricity grid, the grid connection also, as you can see on the diagram on the screen. So the battery system is usually connected to the electrical grid, maybe through some sort of panel or switchgear that is usually at the host site. And then, so this connection would allow the system to interact with the grid and perform various functions based on the load and grid conditions. So we also have the battery controller. So the battery energy storage system is, is usually equipped with a controller, right, that manages, so this controller manages the charging and discharging processes while also considering like any grid constraints or regulations, right? So the controller would also monitor things like the energy demand and battery status to optimize the system, overall system's performance. So controller also supports the various communication protocols and, and also helps with data acquisition from the electrical meters, right? And then, so you see also there's the electricity meter, but typically there are two types that will be installed, where we are on the site where we have the battery energy storage system also installed. So you would have the battery meter. And so this is usually like installed between the controller and the battery. So now this meter measures the flow of electricity between the battery and the controller, right? So accurately recording like the amount of energy being charged or discharged by the battery. And this battery meter would also provide like the data needed for monitoring the battery's performance, the energy flows, and efficiency, right? And so we also have like the site meter. So usually at the site also there's a meter called site meter deployed, and then the meter would measure the overall energy consumption and generation of the sites, including both the energy supplied by the battery and like the energy drawn from or exported to the grid, depending on the configuration available at the site. And so this site meter would also like provide the data for billing purposes and performance monitoring. And then the last one is the portal, like the operator portal. So depending if you're doing third-party operation or in-house operation, but there's usually like a portal that is web-based, is a web-based interface or a software platform that allows the system operator or owner to remotely, monitor and control the battery energy storage system. So from this portal, right, you can collect data from the battery meter, the site meter, and other sources to provide real-time information on the energy flows, the battery performance, the state of charge of the battery, and the grid conditions. And then also the portal will also allow the operator to make adjustments, analyze the performance to optimize energy management strategies. Right, so next slide, please. So in terms of like installation of the battery energy storage system, so it's been like it's most common for the installation to be done for either a manufacturing site or an industrial site and a commercial site, like an office building. Or from an operation perspective, in terms of like charging and discharging of the batteries, right, there are different operation perspectives. for the manufacturing site and the commercial buildings, right? So because the commercial buildings and the manufacturing site, they have different energy demand profile, right? Which makes, consideration for charging and discharging different for these customers. So what you would see for an industrial facility or a manufacturing site would be like the loads are unpredictable and then they change according to the production schedule. So there's typically high amounts of load fluctuation and peak demand period, and the peak demand period, can sometimes be unpredictable, yes, for a manufacturing site. So you have to make sure the charging is carefully planned to avoid charging during periods of high electricity demands. So for operation for the office building site, next slide, please. Operation for the office building, for that office buildings, you would see that their loads are more predictable and they have a seasonal load profile. So for most office building, you would typically want to charge overnight because that's when you have reduced activities and reduced electricity consumption. So if you charge overnight, right, most times there's no risk of increasing the demand charges of the building. And then also in terms of discharging, you typically want to discharge in the day where there's electricity demand, and thereby you can create savings for the customer and also reduce electricity bills. So I would hand it over to Archie now to discuss the savings and revenue stream.
Yeah, thank you. So Funda, thanks for sharing sort of the operational profile of those different facilities. I would sort of frame this as these savings and revenues can really apply to both types of projects. Looking at these demand response, taking a signal from a utility or a grid operator where there's a high demand on the grid and dispatching that battery really can generate a lot of value for a project, so high potential value there. Frequency regulation, this is supporting the grid with very, very small, same for reserve markets as well, very small changes in dispatch to kind of keep this very complicated grid balanced, if you will. Coincident peaks is actually a peak power specialty. So forecasting when these coincident peaks happen on the grid, when there's going to be the highest amount of demand. And here in New England, that's going to be typically on the hottest summer weekday afternoon this summer. And so pinpointing that and then discharging the battery to lower the demand during that time really generates a lot of value for a customer. Oh, go back one slide. Energy arbitrage, which is kind of simple charging when it's cheap and discharging when it's higher. We see that more with, I think in California more frequently, but it kind of applies to anything that has an on and off peak rate, right? Because it's going to be cheaper off peak. So a little bit less potential value there, but still a way that kind of the battery generates some value. And then peak shaving, so reducing demand charges, which can take all kinds of different shapes. Sometimes there's a very tiered structure where the demand is much more expensive during certain hours. And sometimes the demand window is the entire day. So different ways to approach that. And we are used to looking at that across different markets.
All right, so this, what you can see on the screen now is an image of the demand profile of a building, right? So so you can see that so the part shown in blue, right? So that's the net load profile, and the part in gray is the demand profile of the building if the energy storage system was not dispatched, which we typically call the gross load profile, and that's what is shown in gray. So from this, you can see that the energy storage system was dispatched during a coincident peak event. So this is what typically is operation during a peak demand, right? So from hours 13 to 15, the net load and gross load are the same. So you can see that the blue line and the gray line, they are at the same point. Because at this point, there was no operation from the battery, we didn't charge or discharge the battery at this point. So if you see from hour 15 to hour 19, you can see the net load, which is the blue line, is lower than the gross load. The gross load is the gray line. So at this point, the battery was being discharged to reduce the low consumption of the site. So at hour 17, where the grid demand was the highest, the battery was used to discharge the most to reduce the consumption of the building from the grid at that hour, thereby reducing the demand of the building during the top peak demand hour, thereby generating savings for the building, right? So this is just like a brief description of how the battery can be operated during a coincident peak event and, generating savings for the site. Next slide, please. So when in charging and discharging the battery for the various value streams, there are some things to put into consideration, and some of the factors have been listed on the screen, so I will just talk about them. So for example, one factor would be battery size in relation to the load. So you have some periods during the day for a commercial building, for example, like towards the evening, the load consumption is lower than the kilowatt hour capacity available on the battery. And for some buildings like that, you're not typically allowed to export to the grid, so it might not be allowed. So in such occasions, right, it's important to be mindful of the amount of kilowatt hour being discharged. And then also, while keeping that in mind, you also have to be monitoring the load in the building in real time in order to make any adjustments necessary, right, to the kilowatt hour being discharged, while, as I said, taking into consideration the constraints, right? Secondly, you'd have there's the non-coincident peak demand. So this would majorly come into play when charging, right? You want to ensure that charging is done during low electricity demand hours. Also, you want to schedule your charge commands in a way that the amount being charged does not increase the peak demand of the building. Because if you increase the peak demand of the building, then you would also increase the utility bills of the building, which wouldn't be great. Also, a lot of these batteries, they have their state of charge limits, right? So the manufacturer may define, the minimum and maximum recommended state of charge levels for the battery. So, you operating the battery within this specified state of charge limits would help optimize the performance and the longevity of the battery. So you don't want to consistently operate at extremely high or low state of charge, because that will contribute to the degradation of the battery. So the third one we have here is we have the charge times. The fourth one, the charge time. So the maximum and minimum discharge / charge time, right? So depending on the load profile of the building, the time frame for charging and discharging could be limited. So you want to charge, during low priced hours, because then you won't, if you're charging low price hours, it's better for your bills. And then you want to discharge during the high price hours so that you can make some, some revenue. You can make some revenue on that front. And also there are some instances that we could have like coincident peak events, like 2 days in a row. And then so you have like a limited amount of time to charge your battery. So, you would have to consider things like that also. And then there's also the charge and discharge rates. So typically the manufacturer will specify the maximum recommended charge and discharge rate for the battery. So you want to ensure you're operating the battery within the recommended charge and discharge rates, so that you can, just to ensure that the battery can handle the power flow, without experiencing excessive stress or degradation. Then there's also the part of the battery health and the cycling amount allowed based on the manufacturer's instruction. So also the manufacturer provides guidelines, right, on the ideal cycling frequency for the battery. So by cycling, I mean, so this is the process of like charging and discharging the battery. So excessive cycling could contribute to, the battery wearing and also reducing the overall lifespan on the battery. So, so it's important to follow the manufacturer's instructions, right, regarding the cycling frequency. This will just help to maintain the battery health and ensure the battery, last long enough, basically. So these are some of the constraints, we will put into mind when we're trying to like charge and discharge, the batteries. So I would hand you over to Ellen now.
Hi, everyone. I'm back. So that concludes the presentation portion, and I see we have some questions. But before we start answering your questions, and just to give some people more time to put in others, we have a poll just to get an understanding of our audience. All right, thank you for everyone who participated. Let me just share the results. Good to know. Archie, I'm going to pass this over to you for the Q&A.
Sounds good. Thanks. We have 3 questions so far, and welcome folks to add more questions, because this is the third of 3 these webinars. So hopefully, if you've been thinking of them and following along, you're ready to answer. All right, we've got some results on the polling as well. Thank you. Okay, so the first question is, what are your thoughts on the argument that commercial battery technology is being updated so rapidly that people who are waiting for it to settle, like say wait 5 years, might work out better, I guess? It's an interesting question. I think we've seen a lot of growth in the industry. And I think there's no getting around that the technology today is lithium-ion batteries. There's other chemistries and applications that are a fit, and there's a whole lot of growth in other technologies. But right now it's lithium-ion. It's the same cells that are powering your phone and your laptop, your electric vehicles. So those are really pretty well built out. I think if you wanted to wait 5 years, you'd certainly be foregoing 5 years of savings at the very least. I'd also add that the operation of storage and particularly batteries allows a lot of flexibility. So unlike, for example, only having solar, when you have storage either by itself or with a solar project, you're able to change the operating profile to respond to different utility rates and structures and incentives. We do continue to expect that those will get better. But I would also say that waiting it doesn't really help. That these projects do take a little bit of time to deploy, which actually leads nicely into the next question. Do battery energy storage systems ever require complicated interconnection permitting process when they're installed behind the meter? So as I was alluding to, it can take a long time to install or to go through the interconnection, procurement, and then permitting and deployment process. So unfortunately, the way that we're typically operating is focused on behind the meter. In some cases, the battery might look to export, and that's a little bit different interconnection process. But frankly, the utilities want to sort of look at a worst case scenario where instead of the battery reducing the building load, they see the battery exporting to the grid, which is not the case in reality, but understanding that they have to build their system for worst case resiliency and reliability, they take this view. So that does kind of slow it down. That's always a challenge with any sort of renewable project, is that interconnection. And I think a lot of folks say if they had a magic wand, interconnection would be the first thing to fix. Let's see some other questions. Is battery health monitored to predict its failure based on cycles? We do have some pretty good visibility through the battery management system and understanding how the battery's been cycled. Obviously, as Funto mentioned, staying within parameters for warranty with state of health and state of charge. Looking at by cell by cell, so really a pretty granular view on the system, we are able to understand how it's performing and if that might trigger something. Funto, anything to add on that
one? No, I think you've answered it pretty well. That's fine. Thank you, Archie.
Sounds good. Okay, and then the last question we have that came in, in case of demand response, how much of the demand covered by batteries, and what is the optimum size of batteries in commercial buildings? Punto, do you want to take a whack at that first, and then I can follow up?
Okay. So in terms of like, so in case of how much of the demand covered by batteries, so I mean the way we size like most of our batteries, the demand that can actually be covered just depends on the maximum size, to be honest, of the battery. You know, like what's the kilowatt hour capacity of the battery installed, basically. And then so for commercial buildings, I mean there are different ranges. So I mean we could have a battery that's 4 megawatt by 8 megawatt hour, right? So I think that's like on an average, like the capacity of our batteries, basically. So yeah, actually, can I add any other thing?
Yep. Yeah, I think it's an interesting question on demand response, and we do see a range of sort of duration on those calls. So in this scenario, you know, imagine a utility is telling us as battery operator, you know, tomorrow afternoon we expect it to be very hot and a lot of demand on the grid. Can you please dispatch the battery from say 5 p.m. to 8 p.m.? So that's a 3-hour window, and you know, if it's a 2-hour battery, we can sort of change the way it's operated to spread it out over those 3 hours. Oftentimes up front, when we're designing a project and sort of modeling what the revenues look like, we want to match the length of the window. So, okay, it's a 3-hour or 4-hour window. We'll likely pair that with that 3-hour, 4-hour battery. And that sort of helps maximize the value of the project. And then, you know, in turn, maximize the amount of revenue that we can share with the customer. So that's a great question. Appreciate that. I think that's all the questions. I think, Elaine, anything else to wrap up with?
No, just thank you so much, Funto, and thank you so much, Archie, for providing this great content for everybody. And thank you so much for attendees for joining us. Please be on the lookout. We have a post-webinar survey that's going to pop into your email or possibly into your screen. And we will be doing more webinars in the future, hopefully some workshops as well. So we appreciate any feedback you can give us to make sure that we create content that's engaging and interesting for you. And that is it. Thank you so much for all your time and have a great day. Thanks all.